I am R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we are going to see the topic Impedance Matching Quarter Wave Transformer for the course Transmission Lines and Antennas. So, in the picture we can see there is a original signal in the blue color, standing wave and also reflection. So, we can infer from this diagram there is a reflection because of the standing waves in a transmission line. So now we are going to see about impedance mismatch and its effects. In a transmission line, if the load impedance is not matched with the characteristic impedance of the transmission line, reflections occur. So this reflections allows the load to absorb the wave energy, which makes the power loss. So these reflections are problematic because they reduce the amount of power that can be transferred from the source to load, and the reflections also lead to standing waves, and the high amplitude portions of a standing wave can sometimes damage the components or cables. And in applications like television picture transmission, these reflections make impairment of picture quality because of the ghost images. And in applications like transmission of pulses, pulse shape distortion occurs. So this makes the problem of frequency stability, and signal strength get reduced, which reduces the signal to noise ratio. And in the picture there is an ideal pulse which will be given at the input side, but because of this impedance mismatch we get distorted pulse at the output side. So for mitigate this problem, we can use impedance matching networks. So the impedance matching networks are also called as impedance transformers because they transform the load impedance to the characteristic impedance of the transmission line, or they will transform the line impedance equal to the source impedance in order to achieve impedance matching. So there are various types of impedance matching networks. Usually the impedance matching networks are designed using an inductance or capacitance and a section of transmission line, and also using LC combination the impedance matching networks are derived, and they use quarter wave transformer, and using a half wave line and eighth wave line the impedance matching networks are derived. Using short circuited stuff, impedance matching is achieved. So in the picture there is a lossless transmission line with characteristic impedance Z0 connected to load ZL. So suppose if Z0 is not equal to ZL, we know the reflections occurs. So in order to overcome this impedance mismatch problem, a quarter wave transformer is inserted across the line, and the length of the quarter wave transformer is taken as lambda by 4 and a quarter of the wavelength. Because of this is called as quarter wave transformer, and the input impedance of the transformer is designed as Zs equal to R0 squared by Zr. And other applications are they used as a transformer, impedance inverter. These quarter wave transformers are used to couple a transmission line to resistive loads such as antennas, used if the load is not pure resistive, used as an insulator. And assessment: design a quarter wave transformer to match a load of 200 ohms to source resistance of 500 ohms. Operating frequency is given as 200 megahertz. So in this problem we can easily design a quarter wave transformer. First we can design the length of the quarter wave transformer. L is equal to lambda by 4. So lambda is not given in the problem, but the frequency is given. F is equal to 200 megahertz. So lambda is calculated from this frequency by the formula lambda is equal to C by F. So here C is velocity of light, 3 into 10 power 8 meters per second by 200 megahertz gives the value of lambda. By dividing the lambda by 4 we can get the length of the quarter wave transformer. and input impedance of the transformer is designed Zs equal to R naught squared by Zr. And in this way we can easily design a quarter wave transformer in order to achieve impedance matching. The second question, the effects of impedance mismatch, we have discussed already. Pulse distortion in pulse transmission applications occur, and ghost images in television signal transmission occurs, and signal distortion which reduces the energy of the transmitted signal, so the power loss occurs. So these are the effects of impedance mismatch in a transmission line. References. Thank you.